Alrighty, so we are on 3.1, adding and subtracting radical expressions. So we're going to add radical expressions and we're going to subtract radical expressions. Okay, so we're going back to the whole kite problem from the last lesson. It says members of the Windy Hill Science Club are building box kites to explore aerodynamic forces. The frame of a box kite has 4 legs of equal length and 4 pairs of crossbars, all of equal length. The crossbars are attached to the legs so that each crossbar is positioned as a diagonal of the square base. The club will provide balsa wood for the kite's frames. The club advisor wants to find the total length of the balsa wood needed. To do so, he will need to add radicals. You already know that you can add or subtract like terms in a variable expression. For example, this one below, we have 5x plus 7x. We know that they're like terms because they both have an x. So 5x's plus 7x's equals 12x's. When you add or subtract radicals, both the root index and the radicand must be the same. So both the root index and the radicand must be the same. What does that mean? That means that the type of square root it is, like if it's a square root, cube root, fourth root, they all have to be the same kind, and the number or letter inside has to be the same. Okay, so let's take a look at example A. I'm going to do it off to the side. Let's start with letter A. 3 square root of 5 plus 7 square root of 5. They're like roots because they're both square roots and they both have the same number inside. So the same root index, they have the same radicand. So they are like terms. So we can combine them. So 3 square roots of 5 plus 7 square roots of 5 equals 10 square roots of 5. Easy peasy, right? Letter B, we have 10 cubed root of 3 minus 4 cubed root of 3. Well, they're both cubed roots. They both have the same number inside. So these are like terms, like radicals. We can combine them. 10 cubed roots of 3 minus 4 cubed roots of 3 equals 6 cubed roots of 3. Letter C, we have 2 square root of 5 plus 8 square root of 3 plus 6 square root of 5 minus 3 square root of 3. Okay, well, I have square roots of 5. These are like terms. 2 square roots of 5 plus 6 square root of 5 is 8 square root of 5. 8 square root of 3 minus 3 square root of 3 is 5 square root of 3. And these are not the same number under the radical, so we can't combine them any further. So that's as far as we can go. So that's the answer. Turn the page. Let's do the try these A. So we're going to add or subtract each expression, and then we're going to simplify. So we're going to do the best we can to simplify this, if it is possible to simplify. All right, let's take a look at letter A. I'm going to tilt this a little bit because I am left-handed, so I need to go at an angle. All right, so it says add or subtract each expression and simplify. These are like radicals because they both are square roots and they both have a 7 inside. So 2 square roots of 7 plus 3 square roots of 7 is 5 square roots of 7. And then just plus 2/3 because I can't do anything else with the plus 2/3 because it's not a like term. So we just have to write it like that. You have to write it like an expression. Number 5. Let's see. I see like terms here. The root 6's, and I see root 5's. So 5 square root of 6 minus, when you don't see a number there, you always assume it to be a 1. Okay, So 5 square root of 6 minus 1 square root of 6 is 4 square roots of 6. 2 square root of 5 plus 7 square root of 5 is 9 square root of 5. And that's as low as we can go. All right, letter C. The only like terms I see are right here for now, but that 8 looks highly suspicious. I think there's a hidden perfect square in that 8. Let's zoom in and find it. Just kidding. You're not going to find it that way. We need to do a factor tree. 8 is the same as 4 times 2. 4 is a perfect square. Okay, so if we take the square root of 4, the square root of 4 is 2. Done with the 4. And the other 2 is stuck inside. Oh, so we really have 3 like terms in that little math sentence there. Okay, so 2 square roots of 2 plus 2 square roots of 2 plus 3 square roots of 2, 3, 4, 5, 6, 7, is 7 square roots of 2. But then on top of that, we're adding 2 to it. So just plus 2. We can't combine that any further because they're not like terms. So that's it. All right. So number 1, the club advisor also needs to know how much wood to buy for the legs of the kites. They got to go to Home Depot. They need to know how much materials to buy. Each kite is going to be 3 feet tall. Okay. So it says complete the table below. So from the previous lesson, we know that there were 4 pairs. Excuse me. 4 pairs of crossbars. So that means that if there's 4 pairs and there's 2 in a pair, that means that there are 8 crossbars total. We're going to need that in a bit. And from the previous lesson, we got that a 1 by 1 is going to have a length of square root of 2, then 2 square root of 2, 3 square root of 2. These are all from the table from the previous lesson. So we already did these and got these. Okay. So the length of one leg in feet, well, if a leg is 3 feet tall, one leg is going to be 3 feet. So a leg is going to be 3 feet no matter what. Wood needed for the legs. Well, remember there are 4 legs. So if there are 4 legs and each one is 3 feet, we're really multiplying by 4. So we're going to need 12 feet of legs. So 12 feet of wood for the legs is what I meant to say. Okay. Wood needed for the crossbars in feet. Well, since there are 8 crossbars, we're going to need to multiply the length of a crossbar times 8. Okay. So 8 times the square root of 2 is 8 square root of 2. 8 times 2 square root of 2, well, 2 is an outside number, so we can multiply those together. 8 times 2 is 16, so we have 16 square root of 2. 8 times 3 square root of 2, well, 8 and 3 are outside numbers. 8 times 3 is 24, so 24 square root of 2. 8 times square root of 5 is just 8 square root of 5, because remember, that number out front is really a 1. And then 2 square root of 5 times 8. 8 times 2 is 16, so 16 square root of 5. And then 8 times 3 is 24, so 24 square roots of 5. Notice how when we're multiplying by a number, a regular number, the radical number did not change, only the number in front. Okay. So, how much balsa wood should the club advisor buy if the club is going to build the 6 kites described above? So if we're buying wood for all 6 of these kites, A, B, C, D, E, F, we have a lot of wood that we're going to be needing to buy. So first of all, the legs, 12 plus 12 plus 12 plus 12 plus 12 plus 12. That's 1, 2, 3, 4, 5, 6. What's 12 times 6, guys? Don't know? Grab a calculator. 72. So we're going to need 72 feet of wood for the legs. And then we're going to need all of these for the crossbars. Well, let's add up the square roots of 2. We have 8 square roots of 2 plus 16 square roots of 2 plus 24 square roots of 2. So 8 plus 16 plus 24. 48. So we're going to need plus 48 square root of 2 feet for the first 3 kites. Now let's add up the square roots of 5 because those are like terms. We know that 8 plus 16 plus 24 is 48, so that would be 48 square root of 5 feet for the last 3 kites. Okay, so it says explain how you reached your conclusion. Well, what did we do? We added, we added all these. We added all the square roots of 2s. We added all the square roots of 5s. So what did we do? We added like terms. Turn the page. Approximately how much balsa wood in decimal notation will the club advisor need to buy? Use your calculator to approximate the amount of balsa wood and then decide on a reasonable way to round. So we're going to take that number that we got. It was 72 feet plus 48 square root of 2 feet plus 48 square root of 5 feet. And now we're going to figure out, okay, well, how much feet is this really? Okay, so what's nice about this calculator is I could type it all in one line. So 72 plus 48 square root of 2 plus 48 square root of 5. Hit equals. And this is what I get. Now, if I need to go to Home Depot and go buy these materials, I want to make sure I have enough materials, right? It's always best to have too much materials rather than too little materials. Because if you don't have enough, then you're starting all over, and that's not fun. Nobody wants to waste money or time. So when we round this, we probably need to round up, even though that's a 0.2. So I'm going to round it up to 248. So I'm going to say that 72 plus 48 square root of 2 plus 48 square root of 5 is approximately 248 feet of balsa wood that I need to go to Home Depot to buy. So we need to round up. Remember, we're buying materials. So you always want to round up when you buy materials, and that's a real life lesson. Anytime you have to buy an amount of wood or line or chain or whatever, you need to always round up your answer so that you make sure that you have enough. Okay. Explain why the club advisor would need this approximation rather than the exact answer expressed as a radical. Well, we need an exact answer to know exactly how much wood to buy. You're not going to go to Home Depot and tell the guy, hey, I need 72 plus 48 square root of 2 plus 48 square root of 5 feet of wood. They're going to look at you like you're crazy and send you to the mental hospital. Like, oh my gosh. So I probably shouldn't have said that. But anyways, I was just being silly. All right, so we need an exact answer. In order to know exactly how much wood to buy. How much wood could a woodchuck chuck? A woodcut chuck? I couldn't even say it. I tried. Whatever. All right. You can use the addition property of radicals to add and subtract expressions involving fractional exponents as well. So let's take a look at example B, because sometimes we will have fractional exponents. That just means that it's a type of radical. So I'm going to write example B up here. Actually, I'm going to use a darker color because it's hard against this dark paper right here. So I have 4x cubed y to the 1/2 minus x cubed y to the 1/2. So when you have a fractional exponent like that, in order to add or subtract these expressions, they have to have the same exponent, so they both have the 1/2, that's the same, and they have to have the same stuff inside. And by stuff inside, I mean they need to have the same variables. This has an x cubed, and so does this one, and this one has a y, and so does this one. So they have the same stuff, so they are considered to be like terms. So since they're like terms, that means we can combine them. That means we can subtract them. Notice there's no number in front of this one. So that means it's a 1. Okay. And so that means we'd have 4x cubed y to the 1/2 minus 1x cubed y to the 1/2 means that I have 3x cubed y to the 1/2 power. Okay. I'm going to call myself out right now, and I messed up. We can't do that. I just messed up. My bad. Okay. What does 1/2 power mean? Is the way we need to go. The 1/2 power means that this is a square root because the 2 is in the denominator of that power. So we need to actually convert these to square roots first. That was where I needed to go. So I made a mistake. I'm going to own up to that. So square root of 4x cubed y minus square root of x cubed y. Okay. The reason why I couldn't combine these is because the stuff inside was not exactly the same. This one has a 4 and this one has a 1. They have to all be the same, not just the variables. That's where I messed up. So I need to simplify this a little bit more. And I can, which is the good news, because 3 is not a perfect square. Y to the first isn't a perfect square, but 4 is most definitely a perfect square. What is the square root of 4? It's 2. So then we're done with the 4. So we have 2 square root of x cubed y minus square root of x cubed y. Okay, now the square roots, they're both square roots and they have exactly the same stuff inside. So 2 square root of x cubed y minus 1 square root of x cubed y is just 1 square root of x cubed y. And I can go a step further because this x cubed has a hidden perfect square in it. I want to make sure we can see it. X cubed we can rewrite to x squared times x to the first. X squared is a perfect square. And the square root of x squared is x, so an x gets to come out. This x will get stuck inside with the y that we can't break apart. So x square root of xy is the answer. Okay. And that's it for that one. So let's turn the page. And then we've reached the end. So I think your homework, it might be here, but it might be the additional practice. So I'll let you know on Google Classroom. All right, have a good one, guys. Bye.